Hello. This section, the topic of this section is calculating limits using the limit laws. The story of this section is that the functions we deal with are all real value, all real value. If we have an expression such that the value of the f at this number exists, then we say x is in the domain of the function. For example, suppose f of x equals 1 over x, then for non-zero x, this number exists. So we say the domain of the function f, or briefly, domain of the function f is the set of all real numbers such that x is not zero. Domain. Domain is abbreviation of domain of definition. 定义域的简称就是定义域 domain of f. So sometimes when we have an expression, 有一个式子 the numbers such that this expression is meaningful or a real number. 一个数如果代替使它有意义，就是是一个实数的时候 then we say this number is in the domain of the function f. 我们就称那个数字是在 f 的定义域里面。Okay? Well, okay. Now we have some operations. Addition, subtraction, multiplication, and division. We also have important relations. So if we have two functions, one is f, another one is g. No matter x is a number or not. Suppose f of x is, okay, this is a 3, this is 5, and this is 8. G of x is 8. Means f of 3 is 5, and the g of 3 is 8, suppose. Because this is a number, and this is also a number. This number is determined by this relation or rule f and the number x. Also, this is a number. This number is determined by this relation and this number. If we want to talk about the addition, automatically we can add. How to add? If this is a positive, and this is also a positive, this one plus this one means fx plus g of x, 5 units. 8 units, so 5 plus 8. We have f of x plus g of x. So this number is determined by both f and g and the number x. So we have a new rule. We give this new relation or new function the name f plus g. We don't want to use complicated notation. We use plus. This plus is different from this plus because this plus is addition for numbers, and this plus is operation for functions. So we may define the sum of two functions f plus g is defined to be, yes, we use this notation to indicate the left-hand side is new object is defined to be by in terms of the right-hand side. Okay? When we have f, when we have g, and x is given, then this is a number, and this is also a number. We may find the sum of these two numbers, right? Okay, so if x are different, then the sum may be different according to what the value of f and g at x. So we extend the notion of addition from numbers to functions. Certainly, the domain of this new function is the intersection of the domains of f and g. Okay, because in order to this one is meaningful, this one should be defined, and this one should be defined. So the domain of the new function is the intersection, the common numbers, common points of this function, the domain of this function, domain of this function, right? Well, so this is the sum operation of four functions. Similarly, we may define, we may consider the difference is defined to be f of x minus g of x. This one is called the difference of the functions f and g. Of course, we define the product of f and g to be f of x times g of x. Also the quotient. For this, the last one, the domain of the quotient of f and g is, of course, the common numbers in the domain of f, g, and g of x is non-zero. Because if the denominator is 0, this expression is undefined. Okay, it's meaningless. Okay, so it's very easy to follow. Okay, then let's state some limit laws. These are all old things, old objects. Limit is new objects. So we combine the new objects with old objects. Then we have the following limit laws. Is that if this is a number C, or let me see, C or A, okay, A. The limit laws. Suppose in the following, these two limits exist. Exist. To exist. A wrong grammar. English grammar. Suppose these two limits exist. And C is a K is a constant. Then 1. This one, of course, you can write it this way. y almost the same. Replace this one by a, some fixed number a. And there is some number, for example, f may be defined or undefined at a, but f is defined in some neighborhood of a. And all of this mapped by f is close to a. L, similarly, we have a number m here. Then we want to add these two numbers. And these two numbers is the sum of what? Of L and M. Again, if some x nearby A, whose value is very close to L, G, whose value is very close to M, then the sum should be very close to L plus M. This phenomenon is written by this form. So, if we add two functions first, then apply, then take limit here, equals take limit first, then add these two numbers. Here, addition is maybe sum of two numbers, but you can replace this by this form. Okay, replace that one by this form. Our textbook uses this form. I prefer express the expression, use the equivalent form, f plus g of x. So add these two functions first, then take limit equals take limit first, then add these two numbers. These two operations, addition and taking limits, commute. Okay, can commute. Sometimes we say this phenomena by taking limit preserves addition. Preserves addition. 就是说，这个定理呢，虽然很直觉告诉我们，当 x 很靠近 a 的时候，它很靠近 L。For example, very close to 3, almost 5. X close to 3 and almost 8. Then there's some almost 5 plus 8, 13. This phenomenon can be expressed by this one. 可以用这样表示。这个表示怎么样呢？先把函数相加，再取极限。会没先取极限再相加。我们有时候就把这个称为，这个表示说这两种运算呢是可交换的。Are commutative or commutes. Taking limit and sum up, summing, commutes. 或者是说取极限呢可以保存加法运算。Taking limit preserves addition. Preserves addition, the operation addition. Similarly, we have taking limit preserves subtraction, 保存 就取极限然后保存减法运算，大前提都是这样。We have a big if here. If these two limits exist, okay? Otherwise, we cannot add two non-exist number. Two numbers which are okay. Similarly, we have this result. Fortunately, we are not a member, a student of math department, or otherwise we have to prove this was too hard. Okay, subtraction. Division.